In the quest to unlock the mysteries of the human mind, scientists and engineers are pushing the boundaries of what was once thought impossible. Brain-computer interfaces, or BICCs, represent a groundbreaking approach to bridging the gap between the human brain and technology.
So it's called brain-computer interface. It means you provide a bridge between the brain process, what we call neural process, and how the computer tries to control the computer. If you believe that all our actions are controlled by our brain, and there are specific signals that can be programmed, brain-computer interface means that we can use neural signal that generate from the brain to directly interact and control the behavior of the computers. Two ultimate questions. One is about ourselves, another is about the universe. One is really small, another is really big. So brain-computer interface belong to the understanding of ourselves. Should we understand the brain in a certain way that we can hijack the signal from the brain so that we can provide alternative communication methods. So in this end, it's very useful for example, provide a communication channel for people, for example, who cannot move or who cannot talk, right? So, for example, like the people who suffer from injury, that they cannot control their muscle, but their brain is fully functioning. Therefore, if we have this so-called brain-computer interface, then we can decode the signal directly from their brain, and then provide the thought, like what they are thinking, directly projected on the computer screen or control the machine, so that they can have a way, alternative way, to interact with the world. Right? So that's one thing. That's a major application right now for the people who suffer from the movement disorders.
James Johnson is one of only a handful of people in the world with an implantable brain-computer interface, a brain implant that enables him to control a computer hands-free using the power of his thoughts alone. James has used BCI technology to create an extensive portfolio of digital art, now on display at the first ever thought-generated art gallery, the BCI exhibit. James Johnson said in his interview, "Art allows me to have an identity again. This technology has given me hope. It gave me hope that someday I will be able to interface with not just a computer, but my environment. So the sky is the limit with things that I could create."
其实脑波它是可以解读你的一个维度的一个数据，通过它的gamma、beta， 然后 alpha 赫兹的一个频率，然后去体现你对当时对这个面前的这个东西的一个是 concentration， 还有一个是 attention， 然后还有一些 relax focus 程度。我当时是截取了一个 concentration 的一个维度，还有一个 attention 的维度，然后去表现用户对于这个装置的一些投入程度以及它的一个反应。我们对于这个脑波的研究其实比较有限，目前来说比较能够有效的去反映我们的情绪状态的，其实这两个维度会比较精确一点。所以主要是用了 gamma 去体现它的 concentration， beta 波然后去体现它的 attention， 实时的去反映它用户的对于这个装置以及装置面前的这个 visual 的一个变化的一个感受。
From enabling paralyzed individuals to regain control of their limbs to opening new avenues in communication for those with speech disorders, BCI is rewriting the script of human capability. The boundary between what's organic and what's artificial is becoming increasingly blurred. The power of BCI raises questions about privacy, consent, and the potential for misuse. How do we ensure the responsible development and deployment of this transformative technology? The question is not just what we can achieve with brain-computer interfaces, but who we will become in the process.